Okay, let me give you a little background on internets first, and then we'll talk about how BGP came to be in a cafeteria in Austin, and some of what the hopes and intentions were that remain unfulfilled to this day. First off, internets happen when you connect networks with routers that have mutually intelligible address formats. The hosts can talk to each other, or the images computed of hosts, and I'll talk about that in just a second, so long as you have a path with these address formats that are shared. Notice that, as far as I'm concerned, or Vince's concerned, non-internet solutions are not offensive if there's an engineering reason for them. So one thing that troubles me nowadays is that we see the IP panacea. Everything over IP is no more right than no IP. Robust engineered systems have alternatives, and they have to be considered. One way that I'm troubled, for example, by this is the belief that mobility should be done only as an internet solution. Well, if you're having a mobile phone, for heaven's sakes, the radios and the cell controllers know an enormous amount about where you are and where you're going. Why shouldn't that information, which is in effect level 1 information, be used to make the roaming more efficient? I don't have any offense for people using their radios to help produce a better roaming or mobility solution. In fact, there's a case to be made that entire cell phone systems should appear to the rest of the internet as purely computed images. Now, what I mean by that, I see someone is, at least one person thought that way. A NAT is a simple example of an internet device that produces image hosts, and those are hosts that don't actually exist save via a computation. Why not have such a similar object control the outer edge of your cell phone network using internally all the information at level 1 and level 2 that you have available to you to make handoffs and predictive decisions, because they know which way your cell phone's going. They know where it is. In fact, the E911 stuff required them to know where it is rather accurately. Go ahead, use it. Don't be afraid of it. And don't be worried that it's not accessible in an internet sense. There's no relevance in an internet sense, so don't tie the two together if they're not required. Whereas from outside the world, you have what amounts to a computed image when you need it. Not every cell phone needs to be instantly and continuously accessible from outside its own network. Compute the image when you need it. It just exists for the time it needs to exist, where it needs to exist, and that's it. No need internally to burden the cell phones with some IP roaming scheme. Okay, so there's a little bit of a rant about just as no internet is no good, only internet is no good as well. It's just not right in an engineering sense, and it makes no intuitive sense from the history of systems engineering. All right, let's talk about BGP for a minute. I can go on about the construction of internets and why what we've seen is nowhere near like what's possible. All of the internet technology now available is just one set of, in my mind, relatively limited choices. There's much more possible that we haven't done. If you want to work in that area, the future's bright. There's a lot to be done. There's a lot possible. So, BGP. BGP came into existence because we perceived a crisis with the way EGP, a protocol most of you have never heard of, and it's not worth looking at, because it's a centralizer. In other words, the tributaries go up to a centralizer, and you get your distributions back from the centralizers, and it's just no bueno. There's no future there. BGP was intended to be a much more generalizable solution. It was intended to, first off, not be a routing protocol. just at the time we were doing this, there was a tremendous controversy about decision procedures in routing protocols. And by that I mean the fundamentally different models of some augmented link state versus some augmented distance vector approach. You can find proponents of any computational approach to this day. So rather than have that fight, we decided what we would do is to produce a protocol that was reasonably scalable and had the potential of extension to arbitrary path properties. Our idea of a path property was not just the topological distance, in other words, not just hop count, that it would include, say, how much bandwidth you were willing to accept to that destination. Perhaps by appropriate property aggregation, we would be told what the second choices were, or the second hop ASs and second choice ASs. The reason for that being, I think by now people are aware that if you get some of that information, you can pre-compute rational fallover strategies when things fail. And there is essentially, if there was a gentleman speaking earlier about how to organize a fib so that it can be made essentially hitless. Well, yeah, that's what we had hoped would happen. Unfortunately, it really hasn't gotten there. You don't find much information coming out of most BGPs other than this is where I think I can get, and I'm silent on how it is that I get there in terms of quality, quantity, or other choices. That, in my view, is wrong. Having a BGP decision procedure that censors everything about what goes on is an information hiding exercise that is no longer beneficial. When computation and memory were so very expensive, that might have been a sensible approach. But now, with a reasonable exertion of computer science, and it's not no exertion, trust me, it's not no exertion, but with a reasonable exertion of computer science, you can actually take this information, transmit it with reasonable efficiency, and then do very useful things with the greater amount of information that you get. So the approach of take everything in, run a single decision procedure, produce a single answer, and hide all the rest is just, in a word, wrong. And finally, I think people have perceived it to be not only wrong, but less than completely useful. So perhaps we're going to get some changes here, and I'm all for it. The gentleman, for example, from Catholic University would have had a much easier time of it if he had a little bit of second hop information and some quality information that came along with it. No excuse to not do that nowadays. So there's a little bit of introduction. Oh, BGP, and the way it actually started in part is I had to get two very clever but very hard-headed folks to agree. And they were Kirk Lougheed at Cisco and Jakob Rector, then probably with IBM Yorktown Heights. I'm not sure, T.J. Watson, I think. And those are, those of you who know them know that they're both quite capable, but they have the ability to have strong opinions. I see some of you have met them. Okay? And nothing wrong with that. There's nothing wrong with having a personality and having opinions so long as you're willing to listen to what other people have to say on the subject. And I could eventually get them to agree that this path information approach was something that was viable and that we should give it a try. Now, why TCP? Well, all the other protocols that were doing routing at that time had some sort of error control mechanism. And generically, the approach that is most commonly taken comes from the communications world called ARQ, which essentially is acknowledge and retransmit on error. Well, why reinvent it? Let's just use TCP and get on with it. Now, whether you had to run it over IP or not was actually a separable question. TCP works just fine without IP. You have there's a few issues to overcome. You have to do a slightly different checksum pseudo header, but there's nothing wrong with TCP without IP if you just want to run point to point. Still, rather than reinvent this, I just thought we would just as well agree that we could use a mechanism that we had. Sure, it has various flaws, but it would get our particular problem solved in a year, which is about when we needed it solved, and it did. So that's where that came from. Getting these two fellows to agree on just about anything was, I regarded, quite an achievement. Ultimately achieved in an extended delay of lunch in the Austin cafeteria at the then Microelectronics and Component Consortium. I think that was what it was called. And we did get the protocol written, and you're using at least a descendant of it, although, as I've commented, perhaps in a more limited way than I hoped. I have other things I can talk about, but why don't I try and answer some people's questions? Anyone want to know either ancient history, current history, theory? I can tell you a lot about the physics of optical fiber transmission. I think I could probably bore a lot of you. So with that threat.
Hi, I have a question about your opinion on the lack of adoption or implementation of things like bandwidth information inside BGP, and that maybe, do you think it may have come about due to the fact that people were reluctant to expose that information about their network to their neighbors?
There's a commercial issue for some folks, and I hope that's going to fall away. You can, well, you can always lie, first off. There's no reason that if someone wanted to, they couldn't just say, as much as you care to send. And that would be an answer, but not a very useful answer. Clearly, the recipient of such a thing essentially treats that as no information and says, all right, I'm constrained by the link that I'm going to use, and perhaps I'll derate that a little bit myself. Routing on the basis of other than topology is a little bit tricky, especially if it's going to change in real time. The whole subject of what's called flow variation routing, where you actually dynamically vary your path choices with traffic conditions, is quite a challenge to maintain stability over a large area. It requires either reasonable assurance that everyone's making decisions on similar information or a centralized decision maker. Probably not the right answer. So, yeah, there's a commercial problem with disclosing some bandwidth aspects, but I'd also like to believe that nowadays there is quite a bit of commercial understanding of each other's networks. It's not easy to hide if someone cares to look.
Thank you.
So, yeah, there's a commercial issue, but I think the technical issues will eventually trump that.
So, Len, I think the future of the Internet is going to be very mobility-based. It's a huge market. There's a lot of players that are involved. Have any words of wisdom on how to scale mobility? Because it's a very tough problem. The people in this room only know how to scale it by doing stuff at L3. Do you think there's other paradigms where you can get mobility to work, you know, handsets on high-speed trains and planes and mobile networks, that sort of thing? Any thoughts?
Sure. I think that it would be a great pity to try and have a level 3 only solution for mobility. You're throwing away information that the networks and the underlying transport mechanism know in the name of something that you can't use. It's just not likely that you're going to do intercontinental roaming. You need a level 3 solution if you're going to go over enormous distances at very high speed. It's now true, for example, that you can't keep a phone call up over many stretches of the U.S. interstate system, not because you can't get a signal. It's not RF reachability, it's financial reachability. The network that you're getting a reasonable signal from doesn't have an commercially acceptable way to get paid, and so they just say, no, we're not going to handle your traffic. So don't worry, I think, about what happens in mid-Montana, that you can't keep your phone call up continuously across the whole state. You can't do that now, and you're unlikely to unless everyone's going to flood all of that area with all of their networks. I find that commercially unlikely. So it's not just a level 3 solution. I can argue that the level 3 part of that is the least important part of mobility, and that the most important part is to be able to have effective regional mobility. If you could drive from, let's say, Washington, D.C. to New York and keep your phone calls up, isn't that the practical answer for perfection? Do you really care to be able to fly across Baffin Island on your way to Iceland and keep your phone call up? Is that so important? Well, the transmission technology doesn't permit you. So level 3 roaming, in my view, is very important for very high speeds and very long distances, and not so important for the distances and speeds that people actually care about. So I think that it would be a great pity to have only a level 3 solution. Let's go over here.
Yeah, Joel Yeagley. This body and the IETF have actually spent, a fair amount of time discussing the utility of jacking up BGP or IP and putting in a location layer that exists outside of IP. Would you care to comment on that? And I guess potentially on what you see the future for BGP as?
Again, there's nothing intrinsically wrong with non-internet solutions, even if they're solving internet problems. So I'm not offended by that prospect at all, but the devil dwells where he always dwells, and that is in the details. How it's done, how it's represented, and to what extent information can be substituted, aggregated, and even hidden are crucial decisions at a very high level that have to be made for these things. Part of the reason that I think people do first look to IP nowadays is those issues are pretty well resolved, and you don't have to talk about them and engineer them anew. Whereas I would guess that the proposals that you describe of that nature have been advancing, to be polite, slowly. And those conceptual barriers are some of the reasons for that lack of speed. So I'm not offended by a non-internet solution there. It doesn't bother me much, provided that you have the appropriate intellectual framework to let people make choices with more than one worldview. The recent issue with Estonia, for example, is one where just because one country is mad at another, that doesn't mean that the rest of us ratify any actions taken by one side or the other. The mechanisms we produce have to be robust in the presence of disagreement, and they should work as well as they can with those who agree. So again, adding sort of out-of-band or encapsulating or envelope information in a non-internet sense is not a problem for me. The problem is the conceptual framework that you have to construct each time, and that'll slow it down.
Alex Pilosov. I have a question. In network equivalent of Moore's law, where we see the bandwidth doubling every year, and we seem to have, from yesterday's presentation on 10 gig versus 40 gig versus 100 gig, some real physics issues in scaling the capacity. I wanted to ask if you foresee a brick wall coming up sometime where we cannot scale our capacity any longer.
Okay, well, when I learned these things in the 60s, we had anticipated that ultimately computers would be little glowing golf balls with microwave connectors, and it was our fervent hope that this would not happen on our watch. I'm afraid we lived too long. So there's the problem. It's getting power in, getting heat out, and getting your signals in and out. With any communication technology that depends on essentially radio waves, and that includes fiber optics, the physics gets a lot harder as you cross somewhere in the single-digit gigabit per second range. My version of why people misperceive this is, well, here you were, you had this OC12 stuff sitting there and you were selling it, and then, by golly, this internet stuff hit in the late 90s or mid-90s, whenever the marketing men were there. So they got Quark Express out and they pulled in their data sheet and they edited it up, and they fixed a few of their typos, and then they went to lunch. And they were done. Okay, and the boys in the labs, cursed a little bit and said, well, gee, they're hurrying us up. All right, let's go change the clock on this. And they were real scared of that 600 megabit stuff. So they did a very careful board layout job, and the RF stuff was very carefully done. And so they changed the clock, and it almost worked at 2.5. And with a little bit of cleanup, they actually made that work. And they thought that was pretty swell. Well, a few years go by. I guess it gets to be 2001, maybe 2002, and it's time to make the promises again. So the marketing guys get Quark Express out, and they pull in the old data sheet, and they edit it up and do the same thing, and then they go to lunch, and they're done. So there wasn't any difference as far as they were concerned. Now the boys in the lab, a few of the older ones said, fellas, this is about to get hard. You now have a carrier that is what we used to call X-band, and they actually used to be metallic waveguide that you used to move this stuff around. Okay, then, we're going to give it a try. And it didn't work. And it didn't work the next year. So right now, we're in the circumstance where we'd like to write a PO for 500 or 1,000 10 gigabit per second WDM grade lasers, and no one will deliver them this year. So all those folks who were up here telling you how readily available it all was, let me give you a reality check. When you come to write a check, it isn't quite so easy. And the 40 gig stuff, well, everyone's hand-tuned. You want to buy 1,000 before the end of this year? I don't think you can. You want to get them commissioned before the end of this year? I think it unlikely. So I'm optimistic about making it all go faster. That's sort of maybe not what you would conclude. But I have to tell you, the pace is going to be a bit slower, and the costs are not going to be what you would hope for. So yeah, I think we're going to make it go faster. I think we're going to get 100 gig single streams down fiber, but not this decade. So I'm optimistic, but not perhaps the way that other people think. I think we're getting near the end of our time.
We've got 5 more minutes. Let's do Tony in the center and then Tony on the right. So,
okay.
Go ahead, Tony Hang.
Tony Hang. Well, I agree with your earlier point about mobility shouldn't be limited to layer 3 only. There are mobility things that could be done with the cell phone beyond long distance, right? As I'm moving, in particular for cost, I may want to actually use an 802.11 access hotspot that is available to me because it's lower cost, and then roam out to the traditional cell phone carrier as I am traipsing across Montana, right? And so there are some pieces of this that we need to keep in mind that, yes, mobility is probably best handled within the radio fabric, but as soon as you switch radio fabrics, you're probably switching providers, and maybe there's some more pieces of that. Have you got any thoughts about, where this technology is headed beyond just the simple, 100-year-old approach to the telcos are in control?
Well, I think it's more than 100 years, and the ghost of Theodore Vail is still haunting us. That's part of why we're having such problems delivering the real internet to the users. Nonetheless, the problem of the situation that you just described is what I call financial reachability, that it's more a business problem than it is a technical problem. I think with a dynamically assigned pool of addresses that you just sign up for through a service, if you were able to get, in effect, ISP connectivity from your cell phone provider or your access point, you could just as well have the same effect. It's a man in the middle. It's not particularly desirable, but if you have enough of them, there at least is a conceptual way around the problem. Once again, a computed image of a host. So My problem is I'm not optimistic that the finances will ever, well, ever is a long time, but in my lifetime be worked out so smoothly that the situation you described can easily work. I'm not so optimistic on that one.
Hey, Tony, before you go, Tim, if you're in the room, can I get you to come up here since you're next? Tim's not in the room? Oh, there he is. Yeah, okay. Go ahead, Anton.
Thanks. Tony Capella. Excellent discussion, Len. Something hits me that when we're talking about the mobility questions, that perhaps the right solutions and the ones I've observed to be better than others tend to look at things from a very high overview, scheduling globally, if you will, coordinated, centralized authorities that control the activities of all the actors, all the people in the network. Those seem to be, in my limited view, a good thing. How can we apply that, back to another kind of tangent here, to the standard routing paradigm where the computations are all happening everywhere? Every router does the same or very similar work. I guess what I'm asking is, what do you see, what do you think about when someone says centralized control plane?
I see danger. When I worked for Bell, we were very conscious that the phone network that we'd built had the unattractive property that its single user reliability was an exponentially decreasing function of its size. And that is a property of many centralized solutions. And so our solution was to produce components that were supremely reliable. And thus you got rhodium over gold plating on contacts and things of that sort. Just conceptually, there's the possibility of producing a robust centralized solution. But again, I despair of human nature and disagreement permitting us to produce anything like the robustness of a fully distributed solution. I do believe that the ability to have a type of fractal embedding that gives you robustness is very important, and it's hard to engineer the agreements necessary in a central solution. It's not that it's impossible in my view, but I think it's very difficult to get people to agree to that type of approach because it seems so much more straightforward to issue a diktat. And there lies danger. In the end, you can produce a system that will work well for a bit, and then you'll hit a wall where it simply collapses.
I think you've just described every base station and MSC I've ever touched. Thanks.
Well, there you have it.
Thank you, Len. We appreciate it
Thank
very
you all.
much.